So we are in the last topic, and we need to cover six more operators under bitwise. So if we can cover them, so that we will be able to complete all the operators, and we can move to the next concept. Now, so let's move on and let's understand. So why we need to use bitwise operators? So what is the purpose of using bitwise operators? So if you want to do any modifications or manipulations at a bit level, so I will give you a number, and on that number you want to do manipulations at a bit level. So how you will be able to do any manipulations at a bit level? By converting that number into a bits, right? So we have seen the approach of how to convert them into bits, like how a decimal number can be converted into binary and how a binary can be converted into like decimal, right? So we'll be able to understand what we can see numbers, or we can understand numbers if they are represented in decimal format. Like 10. 10 is what here? It's a decimal format. So as 10 is written in decimal format, we will be able to understand that 9, 7. So this is nothing but we call it as decimal format. So whereas computer understands what? Binary format. So binary format is nothing but 2's complement. So using which we try to understand like how we'll be able to do operations at a bit level using bitwise operators. And under which we have how many operators? Under that we have how many operators? One second. Six. Okay. So we have total 7, right? 7 bitwise operators. So what are they? One, I have bitwise form. We call it as tilde. Okay, bitwise not. So this can be called as what? Bitwise not. We have a operator called as bitwise not, and that is represented using a symbol tilde. Okay, so this is the symbol which we need to use for doing the bitwise not operation. And secondly, what we have bitwise and, right? We have bitwise and this is represented using the symbol this and symbol, right? And thirdly, we have bitwise OR operator. Okay, and this is represented using a symbol pipe, single pipe. Okay, and fourthly, we have what? We have bitwise or XOR. We call it as bitwise XOR, and this is represented with the same symbol as we represented using the logical operators. So all are going to be the same, but the difference between the bitwise and logical operators are, so logical operators takes what? Boolean types, whereas these bitwise operators takes what? Always they takes numeric values only. Right now, what are the other types we have? Other operators we have? We have bitwise left shift operator. Okay, so which is represented this way. Okay, left shift. Okay, and we have two more operators which are signed bitwise right shift operator. So which is represented using the symbol signed bitwise right shift operator. So which is represented using the symbol two double symbols. Okay. And we have one more right shift operator, which is unsigned. So unsigned bitwise right shift operator. Okay, and this is represented using the symbol 3 greater than symbols. Okay, there are two right shift operators, one with two greater than symbols, and other one is with 3 greater than symbols. So the difference is one is signed and other one is unsigned. Okay, so what is the difference between signed and unsigned? We will look into it in a few minutes. Okay, now let's talk in this overall. We have covered bitwise AND. We are able to cover what? We are able to cover bitwise AND, right? So let's cover the remaining things and let's see how they will work actually. So how they are going to be used, and when you give you values, how the manipulations happens, how we can understand them, and what is the number that will come as an output with the combinations. Let's see all that. Now let's take firstly, the next operator, let's take bitwise OR operator. Okay, let me take bitwise OR operator, which is represented using the pipe symbol. Now, how this operator works. Okay, so now generally, so you know what is bitwise OR. So when we wanted firstly, why do we need bitwise here? To perform bit operations at a, to do manipulations at a bit level, right? Now let me say I have some numbers here. So what are the number I have? Before that, let's see the truth table for this OR. Let me firstly show you the truth table. Now, what will how many values this particular operator is going to take? It is going to take two operand values. So you will have what? You will have bit 1 and you will have bit 2. Okay, and their combination bit 1 or bit 2. So what is the combination of the result? So bit 1, let's say bit 1 is 0 and bit 2 is 1. So what will be the result at the time? It will be 1. So if bit 1 is 1 now and bit 2 is 0 now, then the combination of bit 1 and bit 1 or bit 2 is going to be what? Is going to be 1 again. And again I have 0, 0, first bit 0 and second bit is also 0. At that time what we will have? The combination is going to be what? So it's going to be 0. And lastly, I have 1 and 1. So now at this time, what is output? The combination of B1 and B1 or B2 is going to be what? Is going to be 1. So this is the truth table actually. Okay. So this is the truth table. Now let's take a number. Let's take numbers and let's try to perform this operation. Okay. So let me put an example and let me say int a is equal to 10. Okay. And int b equal to, let me say, what shall we take? Let me take 3 here. Okay, so I have a 10 and b is equal to 3. Okay, and if I try doing sys out here, means system.out.println, it is going to print the numbers. And if I say a pipe b, so what is the result of this combination is going to be? What is the result that will give you? So it should give you answer as 11. So let's see how we'll be able to get 11. So for which what we need to do now? I need to represent these decimal values into what? Binary values, right? So how to convert a decimal number to binary number? What is the mechanism we need to use? Now what we need to do? The answer is going to be 11. So how to understand this? How this 11 came out of that or B? A of R B is going to be giving you 11 and the values of A and B are 10 and 3. Now tell me how it is able to give you the result as 11. So what is the in which way it is able to give you 11? So for which what we need to do? We need to do what? We need to convert that particular numbers into those operands into binary format. Can you tell me how I will be able to do it? Now let's say is 10, right? So what should I do? How should I convert this 10 to binary format? You're able to remember yesterday I told you how we can do it. Can anyone tell me how 10 can be represented in terms of binary? Using which mechanism? How to convert a decimal number into binary number? Anyone?
LCM.
Sorry?
By using LCM.
Right, perfect. So we need to use LCM and we should be able to do that. Just a minute. Okay, so what is the mechanism I need to use? LCM. So what is it? 10. 2 of, so sorry, 2 of 10. So for how many times 2 can divide 10? 5 times, right? So what is the result that is remaining? 0. The remaining result out of that remainder is 0. Now again divide 5 with what? With 2. If you divide 5 with 2, then what happens? It can be divisible by what? 5 can be 5 will be 2 will be able to divide 5. How many times?
2.
2 times. So it is nothing but 4, which means that I mean anything is pending in the remaining. In the remainder, yes, 1 is pending, right? And again, we have what? 2. So 2 can divide 2 how many times? Once. Okay, 1 time. So let me say 1 here. Then what is it? What is the remainder that is remaining? 0. So what is the number I'm able to get? 1 0 1 0. Right? So this is the binary representation of 10. Okay. So as I want, this is 4-bit. As I want the numbers to be represented in how many bits? 8 bits. Just add 4 more bits here. As that is, as you don't have anything, that should be zeros actually. So I just added 4 more values there. Okay. So that will be represented in 8-bit. Now, this is the binary representation of A, right? Sorry, 10. Now let me put it here. Okay. Now, what is the other value I have? 3. So can we convert this decimal value to binary now? So how I need to do it? Again, do the LCM for 3. So what I should do? So I have 2, which should divide what? 3. How many times 2 will be able to divide 3? 2 times. Sorry, 2 ones are 2, right? 1 once. And what will be the remaining value? 0. Now how to represent this? As I told you, from bottom to top you have to go. Okay, just calculate this, and whatever is remaining, whatever is the remainder, that remainder we have to take from bottom to top. So how to read? 0 1 0, and afterward, as this is going to be a 2-bit, so I want to represent that into 8-bit. Just add those many zeros in front of them. Okay, I need to add 6 zeros. Yeah, I'm able to add. Now this became what? 8-bit. Okay, it became a 8-bit. Is it 8-bit only, right? Yeah, 8-bit representation. Now this is the binary format of 3.
Sir,
Okay,
11.
this is the binary format of. Sorry, one second. Yeah, here it will be 1. So the remainder is not 0, right? It is 1. So this is how we need to represent it. So 0 0 0 0 1 1. So this is going to give you how much? This is going to give you 3. So this is the binary representation. So let's take this and put it there. So what I have B equal to 3, and let me put the value. Let me copy those values here. Okay. Now what is it we need to do? We need to perform OR operation. So I have 2 operands, and on top of this, I need to perform what? OR operation. So how to perform the OR operation? Let's put it. The first thing is what here? I have 0 1. If first operand is 0, first bit is 0, and second bit is 1. So what is the result? What is the combination? See here, you have the truth table here. The first bit is how much? 0. The first bit is 0, and second bit is 1. So what is the output? It is going to be 1, right? So 1. And next, so I have first bit as what? 1, and second bit also 1. So what it will be? It will be again 1, right? It will be again 1. And next, what we have? 2 zeros. If both are zeros, first bit and second bit is 0, you just need to put 0 there. Okay. And what else we have? 1 and 0. 1 and 0 is going to be 1. And 0, all remaining are all zeros, right? Just put zeros there. Okay. So we are able to get what? This is the number we are able to get. Now this binary number has to be converted into decimal. So how to convert this binary number into decimal? Can anyone tell me how to convert this binary number into decimal? So I have a binary representation that should be converted into decimal format. Can anyone tell me how to do it? No, I want this to be converted like what? 0 0 0 1 0 1 1 should be converted into decimal. This is a binary format. 0 0 0 0 1, 0, 1, 1. So how to convert this to binary? It's nothing but just use the 2's complement formula. So for the first one, we say 2 to the power of 0. We say 2 to the power of 0. Right. And second one is going to be what? 2 to the power of 1. And third is going to be 2 to the power of 2. And later it's going to be 2 to the power of 3. And later we have 2 to the power 4. And we have 2 to the power 5. And we have 2 to the power 6. And 2 to the power 7. Actually, this is very difficult to write like this. Let me check whether this will work or not. Not working actually. Okay, let me continue here itself. Okay, so I'm able to put the numbers. Okay, so let me place them at the right places. Now, once you're able to represent everything in 2's complement, now what I need to do? I just need to do the evaluation. So what is the evaluation I should do? Now coming from here, so we have 2 to the power 0. So 2 to the power of 0 is 1. 1 into 1, how much it is going to be? So this is going to result me how much? This is going to result me as 1. Now this 1 has to be multiplied with this one. So 1 into 1. So what is the result? The result is going to be
1.
1. Okay, so the result is going to be 1. And later we have 2 to the power of 1. 2 to the power of 1 is 2, right? So 2 to the power of anything to the power of that number is going to be the same number. So 2. So we got 2. So 2 into 1, how much it is? It is going to be 2. And later we have, so anyhow, the 2 to the power of 2 is 4. Anyhow, we have 0 here. When you multiply that number with 0, it is going to give you 0 only. Now next we have 2 to the power of 3. It is going to be 8. So 8 into 1 is going to be 8, right? So here this is 0, here this is 0, and here this is 0. As we have zeros, I'm just trying to represent them zeros directly. Okay, I'm just representing 0 directly there. All right. So now I'm able to what? One second. So now I'm able to I'm able to multiply that. Next, what I need to do? I need to do the sum here. I need to do the sum. So how to do the sum? Just like this. So you need to add everything that once you are able to multiply with the 2's complement, now you need to add all these values. So when you add all these values, what is that output that you will get? So 8 plus 2 is 10 and 10 plus 1 is 11. So is it what we told? So A or of B. If A is 10 and B is 3, and if you're performing a bitwise OR, the output is going to be 11. How it is going to be 11? So this is what we did. So we converted every decimal value to binary using table, and we are able to do the operation on top of it. And once the binary format of the value came up after the evaluation, we did complements to understand whether the number is 11 or not. Okay. And by this, we are able to conclude that this is how the OR operator will be working. Okay. Remember this formula. If you are able to remember this truth table, then the other things will be easy for you. Now with this, we are done with bitwise OR. Now let's move on to bitwise XOR. Okay, let's move on to bitwise XOR. The fourth one is going to be bitwise XOR. The symbol is this. So how this works? For which, let's see the truth table for this. Let's see the truth table. If bit 1 and I have bit 2, I have bit 1 of bit 2. Combination of these two. So if bit 1 is what? 1 and 0. So then what is going to be bit 1 and 2 combination is going to be what? Can anyone guess? Based on the truth table which we have used for logical operators, can you people guess? If bit 1 is 1 and bit 2 is 0, so what will be bit 1 XOR bit 2? Any guesses, guys? Bitwise XOR operator. Logical XOR operator you are able to remember, right? So in logical XOR operator, when it has given you true and when it has given you false. Yeah, someone is trying to tell something. So bit 1 is 0, bit 1 is 1, and bit 2 is 0. Can you tell me the combination bit 1 XOR of bit 2? What will be the value? Sorry, did you say anything? Okay, let me tell you. It is 1. Okay. Now bit 1 is 0 and bit 2 is 1. Then what will be the result? It is again going to be 1. If both are same, bit 1 is 0 and bit 2 is 0. Then it is going to be 0. And let me say bit 1 is 1 and bit 2 is also 1. In this case also, this combination is going to be what? 0. When they are same, they are 0. When they are different, then it is going to be 1. Understood, right? So this is how generally bitwise XOR operator truth table looks like. Now what I'll do, let's take an example. So what is the example here? I have A is equal to, let me say 10. And I have B is equal to, let me say 3. Okay. Now if I use this out and if I say A XOR operator of B, what will be the result that I will get after evaluation? What will be the result that I will get after the evaluation? 9. So let's try to do it. Let's put it on the binary representation, take the decimal number, put it into binary representation, and afterwards just calculate the result and convert it into binary decimal format again. Okay, so what we do now, let me say A is equal to 10. So when A is equal to 10, what is the binary representation? We have already seen, right? How much? 0, 0, 0, 0. And what is going to be the other values? 1, 0, 1, 0. Previously we did right. I'm just writing that directly. So we have the binary representation for 10. How much? 1, 0, 1, 0. And what is the binary representation for the 3 here? The same. So binary representation for 3 is nothing but this one. Right? Now what I need to do? We need to perform the XOR operation. So when you try to perform the XOR operation, 0, 0, how much it is going to be? 0, 0 solves what? 0. When they are both same, it is going to be 0, 0, 0. So if it is 1, 0, then it is going to be 1. Both are same, 0 again. Both are same, 0 again. So one is 0, another one is not 0, means it is going to be 1. So what is the number I'm able to get? I'm able to get 1001. This is the binary representation that we got for when we do operation XOR operator on 10 and 3. Okay, now let's try to convert this particular binary representation to decimal. It should be able to give us the value for 9. So let's do it. So how to put it? Let's start writing the 2's complement here. Right. So how to write the 2's complement here? Let me write it from 2 to the power 7. So 2 power 7 and let me say 2 power 6, 2 power 1 second. To the power of 5 and we have 2 to the power 4, and we have 2 to the power 3, and I have 2 to the power 2, and 2 to the power 1, and 2 to the power 0. Now let's represent this number. 0, 0, 0, 0, and 1, and 0, 0, 1. So this number I have taken and I have written it here. Now I wanted to convert this into decimal again. So this is a binary representation, right? To understand, I want this to convert it into what? Binary. For which what I need to do? So 2's complement. So 2 to the power 0 is going to be 1. 1 into 1, how much it is? 1 into 1 is going to be 1. Okay. And next, so 2 to the power of 1 is going to be 2, and it is multiplied with 0. Is going to be 0. And next, anyhow, it is 0. Let's put 0 here. We have 1 here. 2 to the power of 3 is 2 ones 2s, 2 2s 4, 4 2s 8. If you write 2 3 times, and if you multiply that, it gives you 8. Now 8 into 1 is going to be 8. And remaining all are zeros, right? Just put zeros. As you have only zeros, if you multiply also, it is going to give you 0. So let's put the zeros. Now once it is done, just add them. And you know how to add them, right? Just add this number, add this whole thing, and you will get a sum. Okay. So sum is how much? 9. Okay. So is this output what we expected? Yes. The same output what we have expected. So when you do XOR operator on A value 10 and B value 3, you are going to get a binary, decimal value 9. Okay. And this previous example will this whole explanation will tell you how to convert the binary to decimal and decimal to binary. Okay. Now with this, we are able to complete bitwise XOR. So we are done with bitwise and bitwise OR and bitwise XOR. Now let's see bitwise left shift operator. Okay. Bitwise left shift operator. Just give me a minute, guys. I'll be back. Give me a minute. Give me 2 minutes. I'll be back. Okay. Sorry, guys. So let's continue. People are there, right? Okay, so let's move on to the next operator, which is left shift. Okay, so let's discuss about the left shift operator, bitwise left shift. The fifth operator we need to discuss is bitwise left shift operator. You're able to follow? You're able to follow, guys? You're able to understand,
Yes,
right?
sir.
No
Yes,
doubt, right? In these two concepts. I forgot to ask you that. XOR and OR. Both are clear, right? No doubts? All right, guys. Let me talk about left shift now. So how this will work? So this is going to shift whatever the number you have taken, it is going to shift towards the left side by one position. I mean, the number, how many, like if I ask it to move by one, it will move by one. If I ask it to move by 10, it moves the positions by 10 numbers. Okay. So to which direction it will move? It will move towards the left. Now let's take a number, like let's say I have A, which is nothing but which is 10. We know how to represent 10 in the binary format, right? So how to represent it? 0, 0, 0, 0, right? A is equal to, let's say, 10, and the binary format is 0, 0. What is it? 0, 0, 1, 0, 1, 0, right? 1, 0, 1, 0. This is the binary representation of what? 10. Now what I should do? Now if I give you, let's say I want this A to be shifted by one position. So I'm saying with how many towards the left, how many positions it has to move. I'm saying it has to move by one. If I say two, it will move two times. If I say three, it moves three times towards the left side. Okay. Now how the movement will be, we'll see that. Okay. Now if I move a decimal number 10 towards the left shift by one, then the value is going to be 11. The result is going to be 11. So how we are able to get this value? Let's understand that. Okay. For which what I need to do? Let me move this by one position towards the left. So I have 0, 0, 0, 0, 0, 1, 0, 1, 0. Now let me move it by one position. So now here we have this 0, right? Okay. Now I as this moves this side towards the left, this direction, what happens? This is going to move this direction. This is going to move towards this direction. Do we have anything here? Once this value moves towards this direction, we don't have anything. Okay. So this is going to be lost. We will lose this now. Okay. This value will be what? This value is going to be lost because there is nothing afterwards. Okay. Now what we have this. Now this will come into this position. This will come into this position. Okay. And now this one will come to this position. So it is again 0. And now this one will come to this position, right? 0. And now this one will come to this position. So it is 1. Okay. And what we have next? 0. And what we have next? 1. And what? 0. And we have something left over, right? In this place, there will be one number which will be inserted and it is going to be always 0. Okay. 0 will be inserted at the last position. Now this is inserted. Understood, right? How the movement is happening? So when with what positions I asked it to move towards the left, with those many numbers, with those many positions, it will move towards the left. Now, as I asked it for one, it moved only one time. If I ask two times means this 0 will also be lost. Okay, these two zeros will be lost, and here two zeros will be added. And this one will move here, this one will move here. If I ask it to move by two positions. Understood, right? So just what we are doing with the given number, with what I'm asking it to shift towards the left side, with those numbers, they will shift their positions. With those many numbers, those many times they will shift towards the left side. Now, what is that we are able to get? Once we are able to shift 10, okay, by what? Once I'm able to move it towards the left by one position. So what is the number I'm able to get? 0, 0, 0, 1, 0, 1, 0, 0. Now, if I convert this into decimal again, so what is the value I'll get? Let's see. So we should be able to get 11. So let's convert this into decimal and let's see whether it is able to give us the number 11 or not. Okay. So now you know the 2's complements, right? So this is 2 to the power of 7. This is 2 to the power of 6, 5. So what is this number? 4. So 2 to the power of 4. 2 to the power of 4 means how much? 2 to the power of 4. How much? 2 into 2. 4. 4 2 is 8. 8 2 is 16, right? Am I okay? Did I write it correctly? One position gone. Okay. So this one came here and this got inserted. So let me count this and let's see. So when I shift it towards the left, so it should become actually 20, not 11. This value should become 20, not 11. So let's do it. Let's see whether it is able to give us 20 or not. Okay. So as I told you, this is going to be 0 anyhow. Okay, all this will be zeros. Now this is having what? 2 to the power of 4. 2 to the power of 4 means 16. How much? 2 into 2 means 4. So 4 into 1, it's going to give 4. Okay, and remaining 2 are 0. Let's leave it. Now, if you sum them, the sum will be what? Sum is going to be 20. 16 plus 4. It is going to be 20. So when you shift 10 towards the left by one position, what is the binary representation that we are going to get? 20. Okay, so we'll get the value as 20. Is it clear, guys? Am I clear with this? Are you able to understand or not? Is it clear? Any doubt, guys? You're able to follow? Okay. So let's look at the next one. Try to respond because I'm not able to understand whether people are, am I audible or not? Because I have some internet issues. So because of which I'm trying to ask you. So try to respond anyway in the chat or here. So that will be helping me whether you're, am I audible to you or not? Now let's look into the next one, bitwise right shift. And this should be signed right shift. Signed right shift operator. So what it is? Just two arrows, two greater than arrows. Okay. So using this operator, we'll be able to do bitwise signed operator. So now the same thing. So left shift operator is able to do what? It is moving the numbers from towards the left side with a given number. Now, if I try to move a number towards the right, so I'll tell a number with how many position it has to move towards the right. It will move to the right now. So let's take A is equal to 10 only now. If I take A is 10, okay. So what is the binary representation for this? For 10? 0, 0, 0, 0, and 1, 0, 1, 0. So this is the binary representation for 10. Now what I should do now? I need to shift based on the given positions. Now I'm saying A, okay, A is 10, right? A, can you just move towards the right side by one position? Why I'm taking only one? Because it will be easy for me to explain. That's the reason. Okay. So you can try with any other number. You can move them based on the positions that you give. So you can convert that into decimal binary and you can understand that. Again, you can convert it into decimal and you can understand how they are able to move and how the result is coming. Right. Now I'm asking A to be moved towards the right by 1 positions. Now what happens? This 0 will come here. This 0 will come here, and the second 0 will come to this position, to the third position, and third 0 will come to fourth position. Okay, and fourth 0 will come to what? Fifth position, and sixth position what we have? 1. And again in seventh position what we have? 0, and again we have 1. And here this 0 will be lost here, and here we have space, right? This space will be taken by another 0. There will be 1 0 which will be inserted. So what is inserted? 0 is inserted here. So what is inserted? This is inserted. Okay, this one is inserted, and here this got lost. Okay, so as it is not having a space in the 8-bit, it was lost, and this was added. Okay, so now once you are able to move 10 towards the right side by 1, then you are going to get this number. Now, if you try to convert this number into decimal format, then you will be able to understand what is the number that we are getting. So what is the number that we'll get? You should be getting the output as 5. Okay, so the output value should be how much? It should be 5. So let's see whether it is 5 or not. So what is the output we got? 0, 0, 0, 0, 1, 0, 1. So if we try to convert this into using 2's complement, if we try to convert that, so we'll get decimal number as 5. Let's see. So this is 2 to the power of 7. Anyhow, it is 0. Let me put 0. This is 2. This is 2 to the power of 6. Now let me say anyhow it is 0. Let me put 0. And next we have 2 to the power of 5. It is also 0. Let me put 0. Wherever I have 0, let me put that. So 7, 6, 5, 4, 3, 2. 2 to the power of 2 means 4. 4 into 1. It's going to be 4. And anyhow we have 0 here. Just put 0. Now this is what? 2 to the power of 0, right? 2 to the power of 0 is 1. 1 into 1, how much it is? It is going to be 1. And if you sum this, sum is going to be 5. Got it? So this is how the bitwise signed right shift operator works. So we have another one. So what is the other one we have? So we have the next operator we have is bitwise unsigned right shift. Okay, the symbol which we use is 3 greater than symbols. Okay, so both signed and unsigned right shift operators works in the similar manner. Okay, but the difference is what? But the difference is unsigned right shift operator will always returns the value in positive only. Okay, so right shift operator, when it is giving a value, that value will be written in positive only. Okay, there won't be any negative number that will be coming. Okay, but whereas in bitwise signed right shift, you may also get, once it is shifted, you may either get positive number, or there is also a chance that you may also get a negative number. But when it comes to this one, it will always gives you what? Only positive number. Okay, it will always gives you only positive number. So in this scenario, it is not giving you any negative number, negative number, but there is a chance. If I have shifted this with some other number, this might also give me a negative number. So giving negative values and positive values is possible by signed right shift, whereas in unsigned right shift, you will never get a negative number. With any numbers you move them, you never get a negative number. You'll always get a positive number only. Okay, that is the only difference between these two. Okay, one will give you both positive and negative based on the position they are shifted, and the other one will only give you a positive number. Is it clear, guys? Still here? Is it clear? Any questions?
Clear, sir.
Okay, so we have a last operator which is pending. Okay, so I just need a good help in doing it. So in the next, I'll try to discuss in the next class. Okay, so the only one operator is missing, that is negate operator. Sorry, yeah, bitwise not operator, which we use the symbol tilde. Okay, so on Monday's class, I'll try to explain this. Okay, so if I'm trying to represent these things in this way, I don't think they are making very good sense. Okay, there is a lot of disturbance with this. Okay, so I'll make sure that my other device is working properly, and I'll try to explain this on Monday. All right. So till here, you guys are able to follow. You have any questions on this topic? If you have any doubts, you can ask me, or otherwise we can wind up. Any questions, or everything is clear? Clear, everyone? You can say yes from your side. Don't think about others. From your side, just mention whether you are able to follow or not. Or if you have any question, just post me. Okay. Anyone else having any questions? Let me know if it is not clear to you. Okay, I'll try to take some more examples and I will try to demo you. Okay. If you are not still clear with this concept, okay, let me understand. Okay, let me know your problem with that. So I'll try to explain it in the next class. All right, guys. Okay, then. So I'm assuming that you have no doubts on this topic. If you still have any doubts also, please, you can post it in the group. Okay, so we'll try to clear it on that. So we'll have our next class on Monday. Okay, we'll catch up then. So we'll try to complete the last operator which is pending in this, and we'll move on to the next topic. Okay, see you on Monday, guys. Bye.